Just need to be prepared. It is going to be noisy, it is going to be messy, but it's going to be a whole lot of fun.
Katrine is a recently qualified teacher and the science coordinator at Bobbing Village School in Kent. Today she is doing a science investigation on sound with a Year 6 group. Katrine kick-starts the morning with a few illustrations of the way sound works. She begins by showing them that despite what they might think, sound travels through water.
Yeah.
James, can we answer that question? Does sound travel through water?
Yep.
It does, doesn't it? Completely. So I haven't been teaching for long. Science was a subject I always enjoyed but never felt confident in doing. So I really wanted to bring the enjoyment back into it, and that's what I've been trying to do with the children.
Science teaching at primary level is affected by the fact that numeracy and literacy have such a great impact on the timetable. So science is often squeezed into the afternoon. With a development of the creative curriculum, science teaching also may become consumed by other subjects, especially if teachers perhaps are lacking in confidence and don't actually feel confident enough to do investigative work with their children.
Okay.
Since she started at Bobbing Village School, Katrine's teamed up with Helen Ward and the teacher training experts at Canterbury to improve the science teaching in the school.
And they've actually supported my learning to actually go, actually, yeah, you do understand it, and these are things that you can try with the children and learn alongside them. And sound is made through a series of what? Harry?
Vibrations.
Vibrations.
An investigative activity requires the children to plan what they're going to do, make choices, and then evaluate as they go through the success or otherwise of their activity, which is much more time-consuming, but for evidence of real learning, is actually worthwhile doing.
In today's investigation, the children will look at the most effective ways of muffling an alarm clock. They will have a choice of materials and will measure the amplitude on data loggers.
How can the sound of the alarm be muffled most effectively? Have a chat with your partner.
So if you put like tinfoil or paper or materials that aren't very thick, then they'll just shake with them and make more sound.
I think the same as Elliot. When you put clothing on, it will cover, it won't move as much as the tin foil, and it won't make as much vibration.
So the children are really enjoying it. They're finding their own questions. They're following their own ideas. There were, you should imagine, probably 5 or 6, maybe 7 different questions being developed from that one global question. And as a result, the children had that motivation to follow something that they wanted to do.
What we do is we do one full investigation once a term. We're not doing those every week. If we were to do investigations, we would make it shorter, i.e. focus on maybe an evaluation, or let's focus on the conclusion, and you'll do a smaller focus. But they need to do, once a term, a full investigation. What could we change? What are the factors, the variables that we could be changing? James?
We could put more layers on.
OK, we could put more layers of?
Material.
Materials, good. Right, we could change the layers of materials. Roland?
Change the type of material.
We could change the type of materials.
Maybe when we were at school, it was method, apparatus, results, conclusion, from the board onto your page without actually integrating with your brain at all. Children at every stage of that process actually had to make choices and think. Now, if they're doing that, they're more likely to actually learn from the process.
What would we keep the same? Jessica?
The place where we put it?
Yep, the place where we keep it has to stay the same. OK?
The distance from the data loggers should still be the same.
Or go over there a bit. I want you to come up with a question on your whiteboard that you as a group want to investigate.
What material will make the alarm clock the quietest?
How much material does it take to completely muffle the alarm?
How many layers will it take to muffle the sound?
Good question, thank you. So you'll need to write the global question, then your group's question, OK? What is your group from your whiteboard? What are you investigating? You need to do, I will change, I will keep the same, I will measure. Okay, right.
Katrine has put the children into single-sex mixed ability groups. Their first task is to write down their predictions, and Katrine has printed off opening sentences to support the less able children.
So you're going to choose one. So is it one layer that's going to be the best? What's going to be the best?
I think that if we test something like tin foil, which we probably will, the vibrations will get into the tin foil and it won't muffle the sound as much as because we might try one of our jumpers, for instance, and that might muffle the sound better than tin foil because vibrations won't go through the jumper.
But some children are more dominant than others, so I give them all a role and responsibility to take on. So you have equipment manager, measuring manager and recording manager. They all get included, not one's left out, and then we rotate the jobs around so they will each get an opportunity of doing all of them.
Next, the children decide in groups what equipment they will need. Then the equipment managers go and collect it, and the investigation begins.
We decided that it didn't make any difference whether it was on the clock or on the data logger, and we decided that if we put it on the data logger it would be a lot easier. That is 88. What if we put it on? I did it without anything on top of the data logger, then it would give us a good idea of what it actually sounds like. Because our highest result was 95 with the tin foil, and it went up to 95 on there, so maybe that particular result isn't as correct as it should be.
So what are you going to measure now? 1 layer, 2 layer or 3 layer? So it's almost there. Is it almost there? Yeah. Okay, let's go.
94.
What we saw today was the opportunity for children, whether they're very literate or not, to be included into an activity where the key thing was the ability to actually use their own intelligence and work in their own way. And how many of those children were actually incredibly articulate, very practical, but maybe their written work needed support. An investigative lesson will enable so many different aspects of learning to occur in a very authentic environment.
And I've done a chart because I think that's the easiest way to hold information.
Recording is very individual. We're all very individual in how we record. Some of us are very visual, some of us like to be quite linear. As long as they're recording the information, it's absolutely fine. Obviously, you want to extend those who are the above average to and push them on a little bit and to become more organised.
But if you ask them what they don't like about science, children of this age will say they don't like writing.
The worst thing about science is writing it up, because I don't like writing.
Because you have to write loads of things about it with the conclusion and the prediction and everything.
Because they recorded at different stages as they went through the work, then actually there wasn't a huge bit of recording that had to be done. And everything from a child's point of view actually had meaning. Whereas often we ask children to record, write things off the board or do whatever, and they don't understand why we want them to do it other than the fact that we want stuff in their books.
The children record results in their own way. Then they all plot them on a bar graph.
We want them to try and draw their own graph, but obviously what they struggle with is where to put the scale, which scale to choose. Colour card a scale to help with the scaling. So having different options, they get to choose, so they're still choosing, but it's there to support them.
So you can draw your line down there, and then you can use these jumps of 5s, but you can stop at 90. Yeah, do you understand that, Harry?
Let's have you on the carpet, please. Well, as a school, our policy is to have carpet time where we do our focused teaching. When they go back to the desk, that's where they do their independent or group activity. With that class, there's a lot of them. They're year sixes. They need something to stimulate them all the time. So short bursts of things. You're not giving them too much information. There's loads of information that we actually covered today. We've recorded our information in our chart, so we've done that learning intention, and we've done it in a bar graph as well. So it should be really easy for us to see the information and the results of your investigation that you've done. Any groups have any data that they thought didn't fit, or what we could class as dodgy data? Bethany?
We started with one layer. As we went up to 3, it got louder, which was weird because we thought it would like muffle.
Yeah.
And then when we went to 4, it went down.
If your results aren't what you expect them to be, then actually you have to really think more deeply than if everything turned out right.
What could have caused that?
I think it was because the noise in the room wasn't like, everyone wasn't like exactly quiet, and other alarm clocks might have been going off at different times.
To extend the other ones, that's where we're looking at level 5, which was the data analysis, understanding what data worked and what was a bit iffy and how to talk about that. That's how we progress for the more able, and also the use of the vocabulary. What has this investigation taught you? What do you now know? What do you now know, Lauren?
I know that when we are doing our alarm clocks, we have to be in a quieter environment.
OK, that would be next time, wouldn't it?
That cotton wool is the best muffler.
OK, that the best muffler you found is cotton wool. Can I ask you? Where are you going?
No, right.
Yeah. Did you put your hands around it at some point? You didn't, you were careful about that.
Yeah, we put it down and then put it there.
And you were holding it from the top, you weren't holding your hands around it. OK, because sometimes that could have a change of effect because your hands are a really good insulator.
The best thing about science, I think, is being able to do all the stuff by yourself and being able to investigate all the stuff.
Well, I think the good thing about science is that you get to do a lot of finding out, and you get to do a lot of you get to do hands-on stuff and stuff.
You get to experiment with different things, and you can play with them to have fun with that lesson.
No, not you.
I kind of like science because you get to do lots of experiments and stuff like that.
They're enjoying it, they're engaged, they're having a go at all these weird and wonderful things, and we actually let them have a go at it.
How many of those children, if we had rote taught them or used books, would have had the same amount of enjoyment, would have been able to remember it and will be able to use it again?
They might not have come out with the outcome that you were hoping to, but they've investigated it, they found it out, they've reasoned what they found out, or written, actually, no, it's not quite right because of this. They've done it all.